High above Earth, where the atmosphere thins and the stars begin to shine, there exists a mysterious and dynamic layer, the ionosphere. Invisible to the eye, this electrified region of our atmosphere stretches hundreds of kilometers above the surface, pulsing with charged particles, auroras, and high-frequency radiation. Once studied only by scientists and weather experts, the ionosphere is now drawing attention from a very different crowd, militaries. In 1993, a quiet facility nestled in Gakona, Alaska, came online. It was called HAARP, the High-Frequency Active Auroral Research Program. Officially, it was a scientific endeavor to better understand radio wave propagation and the behavior of the upper atmosphere. Unofficially, it became the epicenter of global theories and concerns about atmospheric warfare. Using an array of 180 antennas and 3.6 megawatts of power, HAARP can send focused radio waves into the ionosphere, heating it to create artificial plasma clouds, temporary, controlled auroras, visible from Earth. The experiments confirmed that it's possible to stimulate localized ionospheric reactions. Plasma mirrors, artificial lensing, reflected radar signals, communication disruption, all within a narrow band of space. But HAARP is no longer alone. In Russia, the Sura ionospheric heating facility, operating since the 1980s, is now being reinvested in and upgraded. Russian scientists claim to have succeeded in manipulating ionospheric plasma to redirect radio signals over long distances, potentially enabling over-the-horizon radar and stealth detection. China, too, has entered the race with a massive, classified facility in the city of Sanya, Hainan. In 2018, China conducted experiments where it successfully altered the ionosphere over 5,000 square kilometers using ground-based VLF transmitters. Their aim? Strategic communication during wartime, electronic warfare capabilities, and potentially weather manipulation. The European Union, through projects like EISCAT, European Incoherent Scatter Scientific Association, continues to research ionospheric phenomena using transmitters in Norway, Sweden, and Finland. Though civilian in nature, EISCAT's dual-use potential is well known. Even India has quietly begun expanding its atmospheric research programs. With investments in ionospheric studies through ISRO and DRDO, India is exploring the impact of space weather on communications, navigation, and national security infrastructure. These nations aren't just looking up, they're experimenting with how to control what's above. Meanwhile, EMP weapons, once a Cold War theory, have become a modern fear. The United States, Russia, and China have all developed and tested high-altitude nuclear detonations capable of generating electromagnetic pulses. These EMPs, especially when exploded at 300+ kilometers altitude, can cripple entire power grids, disable military infrastructure, and render civilian electronics useless across thousands of kilometers. Today, the U.S. is working on non-nuclear EMPs, or E-bombs, capable of targeting localized areas. Think taking out the power supply of an enemy airfield without launching a missile. China has reportedly field-tested microwave-based EMP weapons mounted on drones and cruise missiles. The CH-4 drone, according to Chinese sources, has been equipped with EMP payloads for battlefield electronics suppression. But behind the technological triumphs lie critical challenges. Creating stable plasma mirrors in the ionosphere remains difficult. Natural variability, solar flares, geomagnetic storms, and diurnal cycles makes ionospheric manipulation unpredictable. Directing or maintaining plasma structures is energy-intensive. HAARP itself consumes vast amounts of power to operate for even brief experiments. And then there's collateral risk. An uncontrolled EMP, nuclear or otherwise, could destroy civilian infrastructure, medical systems, aviation networks, or satellite constellations. Even a test could go wrong. There's also the legal vacuum. Existing international treaties like the Outer Space Treaty of 1967 forbid the weaponization of space, but they say little about manipulating Earth's own atmosphere. Nations race forward, but no global framework exists to regulate or even monitor atmospheric weaponization. Ethically, the question becomes darker. If one nation can control the ionosphere, can they blind satellites? Shut down missile warning systems? Or create the illusion of incoming threats? We are standing at the edge of a new kind of warfare. One that doesn't just involve drones, missiles, or lasers, but the sky itself as a weapon. The ionosphere is no longer just the medium through which war is fought. It is the battlefield. And if you're still with us at this point, fascinated, perhaps unsettled by how invisible forces above us may shape the wars of tomorrow, then do us a favor. Like this video and subscribe to our channel. We're diving deep into the future of technology, warfare, and the secrets hidden just beyond our skies. Because the next war may not start with a bang. It might begin with silence. A radio blackout. A GPS failure or a flicker in the power grid. And by the time the world realizes something is wrong, the first strike will already be over, delivered by nothing more than a pulse and a ripple in the ionosphere.